Okay, so now we have our PWM drive circuitry on the Freescale motherboard here. We have here the MOSFET driver. We have a MOSFET back here. We have an inductor down here. We have a Schottky diode and a capacitor. Over here we have an LM324, which is serving as a times 10 operational amplifier that's reading the sense resistor. The sense resistor is in series with the 51 ohm load resistor in this circuit. We are picking up the PWM signal here, and we also have two analog inputs that are coming in over here. One of them is the voltage sense, and the other one is the secondary voltage sense, which is really a current sense because it's coming across the 1 ohm resistor. Right now the circuit is off. We have 0 volts essentially across the output of the op amp. Remember, the op amp's times 10 of the current sense. So if the current sense sees 100 milliamps, which is 1/10 of a volt across the 1 ohm resistor, the output of the op amp will therefore gain it up by a factor of 10, and it'll appear as 1 volt. So 1 volt on the DVM represents 100 milliamps. The oscilloscope renders a flat line at the top, which means that there is 0% duty cycle because we have a P-channel MOSFET here. Alright, so we're going to go ahead and start up the code here. And as we start up the code, you notice that the DVM registers about half a volt. And that half a volt is because we are in voltage mode, which means that this switch is in the up position. It reads this switch up as in voltage control mode, and then when we put it down, it becomes in current control mode. So at half a volt, we have 0.05 milliamps, which is representing about 2.5 volts across the sense resistor. And as you can see, we have a duty cycle over here at about 50%. A 50% duty cycle represents about 2.5 volts. Okay, so our voltage control system is working appropriately. I have a second load resistor right here. Currently, we just have this 51 ohm resistor, and this 47 ohm resistor here is just kind of hanging there. As you can see, it's not plugged in. And when I plug that in, because we're in voltage control mode, this current here is going to double when I put that in. So here I just plugged it in, and notice that our current doubled. Okay, I'm going to remove it again. The current goes to half, and the current doubles because we have put essentially half, that is, the load is reduced by 1/2, which means the current has to double. That means the voltage stays the same. So the voltage control system is working properly. It's supplying as much current as it wants to maintain the same voltage. And notice that, again, as I plug this in, the duty cycle really doesn't change because we want the voltage to stay constant. And I'm plugging it in and out right now, and you can see the duty cycle remains flat at 50%. Okay, so now we're going to go ahead and change this thing so that it's in current control mode. So I'm going to push down this switch, and as I flip it down, the DVM now registers about 0.1 volts, or excuse me, 1 volt, which represents 100 milliamps. Right? 1 volt on the DVM, remember, is 0.1 volts across the sense resistor because we have an op amp at a gain of 10. Notice that our duty cycle is now changed quite dramatically. Okay, so our duty cycle has changed quite dramatically because we're in current control mode now. And in current control mode, we want to maintain this voltage, which represents the sense current. Okay, so now this extra resistor is just hanging here, and I'm going to plug it in. And as I plug it in, notice that momentarily the control system responds to that. I'm going to unplug it, plug it in, unplug it, plug it in, and it blips, but it gets right back to where it needs to be, which is at about 1 volt, which represents 100 milliamps. So as I change the load value, the ohmage of the load, the control system varies the voltage to keep the current constant. Remember, it wants to keep the current constant now because we flipped the switch down. And notice over here that our duty cycle changes as well. So I'm going to unplug the sensor, that second resistor. Notice that we go back to that duty cycle that we had originally. I'm plugging it in, and now the duty cycle changes because the control system is varying the output voltage to maintain 100 milliamps no matter what's going on. So I'm plugging it in and out, and as you can see, that duty cycle is varying appropriately. And again, as I plug it in and out, the DVM shows that the control system is responding to that change in the load, but it tries to maintain the current at 100 milliamps at all times. And that pretty much sums up this digital control system using pulse width modulation to use a buck converter to both do voltage control and current control.